recording this. So again, we're talking about area, and again, the space a shape covers, and these are the different ways you would write that out. All right, so now we're looking at this shape here, and all I really want to know is the length of each side, okay? Because for area, so we're just going to go ahead and write that shape in here. And let's actually count how many squares we got here. It's 4 by 4. So let's just copy that shape in here on your notebook. 4 squares by 4 squares. Okay. And to find the area, we do the length times width. So really all that is one side times the other side, okay? So here, this is 4, and this is also 4 because it happens to be a square. So the area is going to be equal to 4 times 4, which is 16. Now, it doesn't give us a unit of measure, so we can just say 16 units squared. Okay, so it's pretty simple. You just multiply one side times the other, and that's it. So if I'm looking at this one, I simply just put 16, and you can see it already says square units. It's written out. So you wouldn't obviously have to write that in here for IXL. You're just typing it in. Okay, so that's all you're doing for these. Okay, so now perimeter, perimeter is the distance. So that's distance around a shape. So we want to know how far is it around the shape. So we're going to look at the same example. This is the area, but to find the perimeter, it's pretty simple. I mean, as you guys may already know, you just add all sides. So perimeter, you just add all sides. So in this case, there's not just 2 sides, there's 1, 2, 3, 4 sides, and I would add all of those together. So 4 plus 4 plus 4 plus 4, okay? Because I'm going to add up all sides of that shape. So the perimeter is 16 units in this case. And again, it didn't give us a unit, so I just put 16 units. Okay, so that's how we find our perimeter. We just add up all the sides. So, for example, I'm just going to make up a shape here. We're going to go 2, 3 down, and then 4 across this time. So that side's 3, this side's 4, and if we start with area, the area is just length times width, so it'd be 3 times 4. 3 times 4, which is 12 units. And actually, let's go ahead and give it a unit, all right? So we're going to call this 4 feet. All right, so 4 feet. So we'd actually say 4 feet squared. Okay, and if we went to look for the perimeter now we would want to add all the sides. So 4 plus the other side, don't forget this side, and then the other 2 sides, which are both 3. So I'm going to add up all of those sides. So 4 plus 4 is 8, and then 3 plus 3 is 6. So 6 plus 8 is 14. And for perimeter, we just write the units. We don't have to square it. So you would just leave it like that. Okay, so in this case, in most cases, you're going to end up with something different. So that's a basic shape, a basic rectangle where you know, where you're gonna just where it's pretty easy. You just match up the size. Now I'm gonna kind of jump ahead here in IXL and look at some other problems you might see. So it might give you a shape like this, a triangle, and it's gonna ask for the area. Okay. Now triangle has a different formula. So this is area when it comes to a rectangle or a square. Okay, but for a triangle area, the area is equal to the base times the height. Actually, let me actually write that out. So base times height divided by 2. The other way you might see that written is instead of like base times height divided by 2, you might see 1/2 times b times h. Okay, this is the same thing. It's just b times h, or base times height. So sometimes teachers teach it this way. Where it's divide by 2, and sometimes they teach it with 1/2. Really, this is the traditional way of putting it, times 1/2, but it just is easier to look at and think about when you just divide your number by 2. So typically, a lot of times I just go with this, and I say I multiply my numbers and then divide by 2. So really, if you think about it, it's really the exact same thing as this one, like times width, except I'm just adding a divide by 2. So if I like actually put a diagonal straight across here, that would make a triangle, which basically cuts it in half. And now that gives me formula for a triangle. Here, let's say go straight down like this. It comes down 5 units like that, and then comes across 4 units like that. So here would be 5, here would be 4. And if you guys notice, it is a right triangle. It's not important, but it is good to know. And here, the height is 5. The base over here is 4. So to find the area, I'm going to do 4 times 5, and then divide by 2. So then that's 20. I divide by 2, that's going to equal 10. And I didn't write units, so I just put units squared. Or in IXL, it's going to say square units, which is the same thing. So you just need the height of the triangle. You need how long is the bottom of the triangle. And multiply those 2 and then divide by 2. Okay, so that one, let's just see if we can get this one real quick. So this one, I got to get the height here. So from here to the x-axis is 8, and then on down, oops, sorry, there you go. So from here, at this point at the top to the middle, that's 8. And then on down here, that's 8. So that's 16. And then across, so that's the height. So 16 is the height here. And then across the bottom, 1, 2, 3, 4, 1, 2, 3, 4, it's 8, 10, 14 down here. Okay, so basically we're going to multiply 16 times 14 and then divide by 2. $16 times 14, and then what I can do is I'll actually put all of this. I'm gonna actually click the divide first. That way I can get the 16 and the 14 on top, and then type 2 in the bottom. So it's 112. So that is the area for this shape, 112 square units. Okay. So that's what you're going to get with these first ones. You're going to get simple shapes. Okay. And you just got to get to 50 there. And I think that first assignment. Okay. So the second one is in the worksheet is where you have to think a little bit more. Okay. So let me expand this out. And I'm going to show you guys some examples that are a lot like these. Now here, it's another triangle, but it's asking not for the area, which you could find the area, but it's asking for perimeter. Okay. And the same thing with this kind of weird shape, and this shape, and this shape. Okay. So we're going to look at like one of each of these types of shapes on how to figure it out. Okay. So when you get this type of shape, it's just asking for perimeter. Okay. When we're down here with these shapes, we're asking for the perimeter and the area. Okay. So let's start with a shape that kind of looks like this. And I'm going to go to IXL. This is another assignment that's similar to that. And we're going to create a shape something like this. Okay. So you could start a new page if you need to. Okay. And what I'm going to do is I'm going to create a graph. So that's about 1, 2, 3, 4. It's about 10 units down. Okay, then I went kind of about 5 to the right, 5 or 6 to the left. Okay. Now what I'm going to do, I'm going to go ahead and draw some marks in here. At least 5 away from the middle. So I'm counting 5. So 1, 2, 3, 4, 5. Same thing here. Okay. So my first point, let's go ahead and draw it right here. And that's over 3 up 2. Okay. The next point I'm going to draw is over 1. And I'm going to go down here to that point. Okay, so that's over 1, down 3. So I'll label these points so you guys can see them. So that's -3, 2. And then that is -1, 3. And I think my next point that I'm going to draw is, let's say, where am I going to go with this one? We'll go here. So that next point is 2, 3. So now I'm going to connect those. If you have a ruler or something straight, you can get a book, or if you have another pen or pencil, you can just kind of line it up. So literally I could just take anything, a pencil, and use that as a ruler. Connect my dots like that. Okay, so I'll give you guys a second to, okay, so now again, we're looking for perimeter. Now, this would be easy if like these sides were like straight up and down. Like if it was just like these shapes over here, where it's straight up and down, all I gotta do is count the squares, right? But it's not. They're all like diagonal. So what we're gonna use, we're gonna form triangles, like different triangles, and we're gonna have to find that missing side of the triangle in order to add up each side. So for each one, we need to do that. Okay, so for this one, we're going to start with this one. And I'm going to start from this point to this point. And I'm going to form a right triangle. So what I'm going to do is just draw a line going straight down. My highlighter here. And then one going across like that. And then just a little bit so y'all can see this a bit better. Okay. And I'm gonna go ahead and do that with the rest of the lines. Okay. Let me focus in a little bit so it's clear. All right, so from this one, I'm gonna do the same thing. I'm gonna draw a line straight down until I get to the level of that point. So I can draw a right triangle. And notice how, again, these have to be right triangles in order to do this. Because we're gonna use the Pythagorean theorem and find the distance or the length of that side. Okay, and I'll do the same thing with the top up here. Okay, sorry, now that one's a little tough to see. All right, so now basically what we're gonna do is we're gonna take each of these triangles and find the length of both sides. So here, the length here is 2, and the length on this side is 5. Okay, and then for this triangle, the leg down here is 3. The leg up here is 1, 2, 3, 4, 5, 6. So I'm basically finding the length of all these legs first. The length of that leg is 1, and the leg of this side is 5. All right. So now what I have to do is basically set up the Pythagorean theorem for each of these triangles. So for the first one on the top, I set up the legs squared. So 1 squared plus 5 squared equals, again, that missing length, c squared. And I'm actually going to do this 3 times like this. So for the blue triangle, it's going to be now, I take the 2 legs, 2 squared plus 5 squared equals c squared. And then the same thing with the pink triangle. So now that'll be 3 squared plus 6 squared, again, equals c squared. So what we're doing is we're going to be looking for those 3 sides. And once we get those 3, then we got to add them up to find the perimeter. Okay, so here 1 squared, 1, 5 squared, 25 equals c squared. And then we just work out the steps. So add those up, 26. And that's equal to c squared. Okay. And then the last step here, if you guys remember, when we use Pythagorean theorem, is the square root. And I'm going to save the square rooting till the end, okay? Because I want to do that all at once. Okay, so 2 squared, that's 4. 5 squared again, 25. Add those up, that's 29. So square root 29 and square root the c squared. And then down here, 3 squared. 3 times 3 is 9. 6 times 6 is 36. Okay. And then add the 36 and the 9. So that'll be 45. And I'll square root that. Okay, so I'm basically going to be square rooting all of these numbers to figure out the length of all those sides. And I'm going to do that on the phone this time. Because I know some of you guys use your guys' phones for your calculators. Hopefully there's not too much glare here. All right, so I'm going to bring out the calculator. I gotta swipe down here. Oh wait, do I swipe up? I always forget. Oh yeah, swipe up. Bring out the calculator. Ooh, I don't want that. All right, so again, to get square root functions on this, and I think it's the same thing with Android, basically you just have to flip it. So it looks like that. Okay, so what you do is you type the number first. So I do 26. And then what you're looking for is the square root that has the square on it, the 2, not the 3, because that's a cube root. We want the square root. So I just hit that button. And I'm going to round this to the nearest tenth. So I look at the 9. The 9 rounds the 0 up to 1. So I'm going to write 5.1 here. And when you round, you write these like little wavy symbols, okay? So you write a little wavy symbol with like that. All right, so then I'm going to do the same thing here with the 29. So 29, and then I hit the square root button. Again, you don't have to use your phone. It's just, I'm just showing you guys ways you can do this. Okay, so this is going to equal 5.38. And if I round that, the 8 will round up the 3 to a 4. And then here, do the same thing. So 45, I got to clear it out before I do it. Hit square root, and I get C equals 6.70. Now 0 doesn't do anything to the 7, because remember, it has to be 5 or more. So then you just have 6.7. Sorry, I forgot the little wavy approximation sign. Okay, now to get the perimeter, we got to add all that up. So equals 5.1 plus 5.4 plus 6.7. Just add them all up, and then you'll get your perimeter of that shape. So 5.1 plus 5.4 plus 6.7, that equals 17.2 units. Okay, so if you ever have like an odd shape of something and you figure out the length around that shape, then you can use your Pythagorean theorem if you have a bunch of kind of diagonal lines. Okay, I'll pause that right there for you guys so that you can catch it. Okay, so again, I got my corner notes over here, and this is going to be example 5. This is going to include area and perimeter in this one. So area and perimeter. So just, again, start a new page number, put the example 5, area and perimeter. Okay, so the problems that we would see that look like this would be the ones down here. Now you can see these are rectangular shapes. So just like the problems we saw in the first couple of examples, I need the length of each side, and then I'll multiply that, and that will give me the area. But of course, if you notice, they're all diagonal. So because they're all diagonal, that's going to obviously make it a little bit difficult to find the lengths. Now, if you guys notice in this first shape, notice how this is a square, right? So if it's a square, you know that once you find one side, you have the lengths of every side. So you don't need to sit here and find and individually do the Pythagorean 4 times, because they're all the same. Because they all have triangles that are going to be 4 down, 1 across, 4 down, 1 across, 4 down, 1 across. So don't repeat it. Take a look. And then even when you do the rectangle, you don't need to find the length of TS and UV, because they're the same. So you're only going to need to do it once. So if, in a sense, a rectangular or square shape is a lot easier than doing kind of these odd looking shapes. Okay. So we're going to look at a shape kind of like a rectangle, because obviously that would be the more difficult example to do. Okay, so what I'm going to do is we're going to jump ahead here and see if I can get an example in IXL that is kind of like that. I prefer it to be a square looking shape. All right, so I'm going to set up, again, another graph. I'm going to go 1, 2, 3, 4, 5, 10 units down, so that I can go 5 up and 5 across, or 5 down again. And then same thing going this way, 5 units to the left and 5 units to the right. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. Okay. Now I'm going to put my first point over here at over 2, 2 to the left, up 3. So it's at 0.23. My next point, I'm going to put, let's go over 1 to the right and up 5 all the way to here. Okay. And then my next point, let's come down to, that looks like a good spot. Maybe right here, actually. Yeah, let's do this one. So actually, you know what? Let's come over 1 unit, okay? So we're going to come over right here at 2, 2. All right, so let's see. I want to make sure that this lines up well. So it'll be down 4. So we want to go down 4, and that would be right here. Yep. Okay. So you're going to have 1 point over here at 2, 2 minus 2, and you're going to have 1 point all the way over here right at 5, 0. Okay, right there on the x-axis. Okay, so then I'll connect those together. In fact, let me use a straight edge so it looks nicer. It's a little sloppy. Okay. All right, so again, with this shape, I want to create rectangles. I'm sorry, triangles. So I'm going to start with this side, okay, because we're looking for the, let's start with the area, okay. So we're going to create a triangle here, okay, on this side. And remember, once I find the length of this side, that's the length of this side, right? So I don't have to do that twice. And then over here, I need the length of this side, so that's going to be down to over 3 here. So I only have to do Pythagorean theorem twice here, and that should give me all the lengths. Okay, so the first one, it's going to be, let's see, 5 here and 4 here. And then the second one is 2 here and 3 here. All right, so kind of split my paper up here. And that's my second triangle that I'm going to be working on there. So I got 4 or 5 squared plus 4 squared equals c squared. And then those two legs, 2 squared plus 3 squared equals c squared. All right, so here, let's add these up. We actually just did one like this. Or actually, no, we didn't, I guess. So that's 25 or 5 squared plus 14, that's 16 squared. Okay, and then 25 plus 16 is 41. Oh, never mind, we didn't do the one that was 41, so that's actually different. Okay, then here we're going to have 4 plus 3 squared is 9. And then 4 plus 9 is 13. And then we're going to square root that. Now, because I'm going to multiply this to find the area and the perimeter, I don't need this extra space down here. I'm going to do this a little differently. Instead of looking for the decimal right now, I am going to just take the square root of 41 and multiply it times the square root of 13. Okay, so that way I don't have to like round a bunch of times. I can round at the end. A lot of times when you're working through problems like this, you want to save your rounding to the end if you can. So even when I did perimeter over here, what I could do is just add square root of 26 plus the square root of 29 plus the square root of 45, and then round at the end instead of rounding 3 times. Okay. All right, so here, and then when I find perimeter, I'm going to take the square root of 41 and add it this time. Actually, I don't really need parentheses for the adding part. So I add square root of 41 twice, plus the square root of 13 twice. So that's how I'm going to set this up in the calculator. So I can save myself some time rounding everything. All right, so I'm gonna do this with Desmos, just a little easier to multiply square roots in there. Okay, so I'm gonna do set up parentheses first. I'm gonna do square root of 41 times the square root of 13. And over here we get 23.08. Then I'm going to do this. I'm also going to add. Now, when you add and use Desmos, make sure that you put the plus outside of the square root. So if I hit plus right now, see how it extends that square root line? I don't want that. I want it outside. So what you're gonna do is basically either click right or click to the right and then put plus like this. Okay. And then square root of 41 and go outside again, plus the square root of 13, plus the square root of 13 again. And this way, all I have to do is round once. Okay, so this is 23.08 and 20.01. I'm gonna write those down. Double check it real quick, 23.08. And 20.01. All right, so I want to round that. So the 8 will move that 0 up to 1. So I'll get 23.1 units squared. And then this guy, for the perimeter, the 1 doesn't change that. So we literally just this rounds to 20.0. But if all you have is 0, you don't have to write the 0. I'll just round to 20. Sorry, not 20 units squared, just 20, because we're talking about the distance, not the area. All right, and that is it.